How do you fix a damaged heart? Heart injury typically occurs because of a lack of oxygen supply to the heart, which also causes damage to the parts of the cells which produce energy, the mitochondria.
The only thing we need oxygen for in this world is mitochondria and to start a fire.
Mitochondria are part of every cell in every single organ. This is a very profound area.
What if we could restore injured hearts and other organs by harvesting mitochondria within a patient's own body? That's what researchers at Boston Children's Hospital set out to find out.
Good job. Did you get any shells in there? Okay, you can mix them up. Avery was born with congenital heart disease. On day 3, she developed seizures, and we were told that Boston Children's was coming to get her.
Researchers at Boston Children's Hospital have been studying mitochondria for decades and had the idea to use a child's healthy mitochondria to restore their damaged heart.
So when we originally started this, we thought that just by delivering viable mitochondria back into an area where the mitochondria are damaged, we would have enough energy there to allow the heart to function. Now we know that we get even more, and it does this throughout the heart. It's a game changer.
Despite successful results in the lab, they still had yet to use this procedure on people to save actual lives.
We had developed this idea, had tested it, and we felt that there was a huge clinical need. But making that leap from the laboratory setting to an actual clinical study, it's very hard to get funding for that. And so that's where Ken stepped in. He understood the problem and saw that with an investment, he could really open the doors for a huge therapy. It was a critical moment, it was a critical piece of support, and it got us off the ground.
Avery met the criteria for them to be able to use the experimental procedure that Dr. McCulley had created. Kind of like a Hail Mary, and we're running out of options. It was a terrifying thought. I remember telling my mom that I thought I might have to bury her by my first Mother's Day.
What we do is we take a small piece of tissue from a non-injured part of the body, and then we isolate the mitochondria from them. And once the mitochondria come out, we put them in a solution, and then we directly inject them into the heart. As soon as we gave the mitochondria, the heart immediately came back. It starts beating normally, regularly, and the first words we got out of the cardiologist is, "Wow, what are you putting in here?" It's really something.
I'm Avery and I'm 8 and I love to dance.
Avery was the 4th patient ever to receive a mitochondrial transplant, and it helped save her life.
Since that procedure, Avery is thriving. She still has her struggles and she has scars, she has a pacemaker, but she doesn't let that stop her. She's gone on trips, she's been on planes, she's been on boats. She dances on a team on stage. And how do you thank someone? What do you say to someone who gave you your baby back?
Avery's procedure was part of a study that was successful in proving that the technique was safe. But that's not where the research ended.
Jim demonstrated that it worked in the heart, and that work actually then created this whole gigantic field now. All of a sudden, this whole area has exploded in virtually every organ.
From work that started at Boston Children's with support from Griffin Catalyst, mitochondrial transplants are now being explored around the world to restore hearts, lungs, kidneys, and even help patients recovering from stroke, all with the potential to save countless lives.
The mitochondria that are in every cell of the body except for the red blood cells, and finding the applications are almost universal.